At noon, ship A is 150 kilometers east of ship B. Ship A is sailing west at 35 kilometers per hour, and ship B is sailing north at 25 kilometers per hour. How fast is the distance between the ships changing at 4 p.m.? Okay. I heard Aiden say he was trying to draw a picture. I agree. You're going to need a picture on this one. So ship A is 150 kilometers east of ship B. Is that what we have?
Yes.
Ship A is 150 kilometers east of ship B. So, which way? Okay, wait. Do we know our directions?
Never eat soggy waffles.
East.
Okay. No, wait. Which way did it read? Ship A is 150 kilometers east of ship B. So ship A, ship B. Yes? Now, and I kind of want to label that side 150, but there's going to be a little bit more to it. Okay? There's going to be a little bit more to it. We have to get that far. Ship A is sailing west at 35 kilometers per hour. So ship A is going this way, 35 kilometers per hour, right? All these movements are going to matter. And ship B is sailing north at 25 kilometers per hour. So ship B is sailing north at 25 kilometers per hour. How fast is the distance between the ships changing? So what are we looking at there?
Triangle.
You're looking at the distance between the ships, because if you've got ship A here moving that way, you've got ship B here moving this way. Okay, so we're looking at that distance. Now, okay. Okay, with this in mind, as we generally name our sides, it's going to have to get a little bit more specific because we have that 150 here, right? But hold that thought for a moment. As we generally name our sides, I was going to go more of the XYZ route than the ABC route, with the idea that what is horizontal? X, right? And so, again, we'll come back and deal with this 150 and this X thing again later. But it's kind of the X idea, right? Y and Z. What formula do you see us having to use here? X squared plus Y squared equals Z squared is our general formula. Again, that one side where they said there's a distance of 150 in there, we're going to come, get a little more specific there. What else are we given here? What are we given in the way of rates? 35 kilometers per hour. And what is that? That's the change in X. So X is changing. The change in X over a period of time is changing at a rate of 35 kilometers per hour. No, because we don't have. Oh, you're saying because it's going left? I don't think it would. I think it's one of those things, that whole east-west thing.
It's not really
Yeah.
If you flip
Yeah.
ship around.
So. And then what is this 25 going to be? It's going to be the change in Y.
Yeah.
So it's going to be change in Y with respect to time. So dy dt is 25 kilometers per hour.
Yeah.
How fast is the distance between the ships changing at 4 p.m.? What are we trying to find?
DZ.
With respect. Or evaluate it out.
dz at,
Oh, 4 p.m.
T equals 4. That'd be T.
well, is it 4? Double check yourself.
Noon, 1, 2, 3.
Okay, and that's the catch. What is our beginning time? They gave us a beginning time at noon, yes? So, is that going to be, yeah, that's going to be when t equals 4 hours. Okay, I can't agree there. Okay. As we go, I had us, for our no, we basically stated the Pythagorean theorem, right? Now, with these, the catch is this ship A. It tells us that ship A right now is 150 kilometers east of ship B. But what's the catch? It's sailing west towards it, right? So what's happening to this distance? It was 150.
Shrinks.
It's shrinking, and it's shrinking by a distance of x. So what I'm actually going to use for this side is 150 minus x. Okay? So instead of just saying x squared here, do you see where I'm getting ready to go with this? I'm going to use 150 minus x, quantity squared, plus the y squared equals the z squared.
Is there a reason why you wouldn't just want to find out x first? Could you do that? Because all it would be 35 times 4.
Okay, sorry, I had to process how to, we will eventually find x, but that's a value we'll plug in after we differentiate, okay? We don't know, we're not using the 4 till we're ready to plug in and solve, okay? That's a part of the question of find this at this time. So we will use the 4. We will deal with the 4 times 35 in that business, but not yet. Fair enough? Sorry, it took me a moment to figure that out. Now, let's differentiate. Or we could FOIL that out, but I think I'm just going to differentiate as is. How do we differentiate 150 minus x quantity squared? Okay, it is going to be a chain rule. Outside, it's something raised to the power of 2, yes? How do we do the derivative of something raised to the power of 2? 2 times the 150 minus x. Your power now becomes 1, because 2 minus 1 is 1, times the derivative of the inside. What's the derivative of the inside? Negative 1. Times the derivative of x, which is dx dt, because everything is with respect to time. Plus the derivative of y squared, 2y dt, equals the derivative of z squared, 2z dz dt. Okay. Couple of things that can happen. What do you notice about all 3 terms? They all have a what involved?
Rate.
They all have a rate. Not what I was looking for, though. They all have a factor of 2. Okay. So one thing that you can do
Just take the 2 out.
is basically you're dividing each term by 2. But when you divide each term by 2, the 2's can basically all cancel, yes? It just makes things a little less cluttered. If I go ahead and multiply the -1 times 150 minus x, yeah, -150 plus x times dx dt plus y dy dt equals z dz dt. And the 2's was just kind of an extra bonus. Okay, now it's a matter of, do we know everything? Okay, and somehow or another we do. We just have to find a bunch of stuff, is what it, I mean, you know. We need, okay, so we're trying to find dz of dt, right? So that's the one thing I don't have to worry about right now. I'm trying to find that. I need to know x, y, z, dx dt, dy dt. Now, we already have dx dt, dy dt. So the keys we have to know are x, y, and z, yes? Let's talk about our boats. X and y are the two that we really have to work with. Z, if I recall, is just kind of a, yeah. So, what do we know about boat A? Let's start with boat A. Boat A was going, I know, I'm saying left. It's not left, it was west, right? But going left or west. And at 4 hours, because that's the thing. At 4 hours, how far will it have traveled?
35.
And this is where we're going to do the 35 times 4, right? So x is going to be the 4 hours times the 35 kilometers per hour. And 4 times 35 is 140 kilometers, I think. Okay, so what we know right there, x is going to have a value of 140 kilometers. Now, what about boat B? It's doing what? It's going up or north. That's going to be equivalent to the y value, right? What do we know about that boat in 4 hours? 4 hours times the rate of 25 kilometers per hour, and that's going to give me 100 kilometers, yes? Now, we have x, we have y. What we don't have here is z. We need to find z. Pythagorean theorem, except we need to use this tweaked version of the Pythagorean theorem, because this is not just x. It was started at 150 and we're taking off that x. So we're going to use the 150 minus x squared, minus x quantity squared, plus y squared equals z squared. We're going to use that to find our z. So 150 minus 140 quantity squared plus 100 squared equals z squared. 150 minus 140 is 10. 10 squared is 100 plus 100 squared is going to be 10,000. I know z squared is going to be 10,100. I got z as the square root of 10,100.
It's like 100. But fine.
I say it's not 100. It's got to be 100. You know. So, you can go ahead and use a decimal. If so, you have to use multiple places of the decimal, or we can use this and come up with the decimal answer later. I do have a final answer decimal, but I have it that we can figure it out later. Okay, you with me here? So we have x and y, and we now have z. Okay, let's go back and fill everybody in. Negative 150 plus x. What's x? 140 times dx dt, so times 35, plus y 100 times dy dt 25 equals z square root of 10,100 times dz dt that I'm trying to find. Okay, and if you have to give a decimal answer, you're going to have a calculator on this. Okay, just kind of depends there. Let's see. Negative 150 plus 140 is negative 10 times 35, negative 350 plus 2,500 equals square root of 10,100 dz dt. What is negative 350 plus 2,500?
2150.
2150. So what's dz dt going to be equal to? The square root. Are you guys with us? So dz dt is going to be the, what'd you say, 2150 divided by the square root of 10,100.
We're getting 21.39.
It's AP Calc. You can't stop at 2 decimal places.
393.
Gotta have 3 decimal places. Okay. So 21.393. Not just kilometers, it's dz dt. Kilometers per hour. And this would be at 4 p.m. Okay. And that would be why we did not go into that one yesterday at the end of class, because we wouldn't have gotten through it. How did all that time go by? Exactly.
I swear the beginning of the class was super fast.
What
It
time?
does.
And then it gets slow. Right about now.
Okay, well, it needs to slow up because I wanted to do 3 more examples. Now, I will say, my other 3 examples are not nearly as big as that one was.
We spent 20 minutes.
What time do we?
I know.
What time's the boat get into this class?
12:30.
So it's
Well, 33 is when we leave
So
lunch.
36
So
37.
or 37.
37 is when our tardy bell rings.
Okay.
So it's not as much
It
time,
is.
but
When
still.
does it end?
But it's still that.
We
Yeah.
spent 20 minutes.
Okay, anyways.
No, there's a lot of homework problems this week. Can we walk now?
Example 6. A right circular cylinder is changing shape. The radius is decreasing at a rate of 2 inches per second, while its height is increasing at the rate of 5 inches per second. When the radius is 4 inches and the height is 6 inches, how fast is the volume changing? Notice what it says, given.
Volume.
Volume equals pi r squared h. So what goes in my no box? Now, why are they giving you this volume and not the other? I don't know. Okay. Remember, volume of 3-dimensional shapes, like a cylinder where both ends are circles, it's the area of the base times the height of the object. So that's pi r squared times height. Okay? Okay. What do you want me to put down?
Oh, that's a given.
Okay, what am I putting in given?
AR-13
Yes? Are you guys with them? change in radius, so dr dt, it's decreasing, that's negative 2 inches per second. What else?
DHDT equals 5.
Okay. The height, dHdt, is increasing. So positive 5 inches per second. When the radius is 4 and the height is 6, how fast is the volume changing?
That's
So
gonna be
R equals 4 and H equals 6.
Yeah. When R equals 4 and H equals 6, what is it we're trying to find? dV dt. Because the question was, how fast is the volume changing? Okay. Okay. Now, we kind of skipped over the drawing a picture here. I don't know, is a picture really necessary in this one? I mean, other than, I would say, you get the right idea with a cylinder, yes? Cylinder is a can, where you've got radius and you've got height. I don't know that you really have to have a picture on this one. I guess in my notes I have the height defined in there, but Okay. So my formula is V equals pi r squared h.
You can put the pi up.
You could do this either way.
Oh,
I'm trying to think.
Yeah, because it's.
I like that little trick.
Yeah,
You like putting that pi
Yeah.
out front?
I did too.
And actually my notes I didn't write here, but I'm for it. So if we do that, you're putting the pi out front, and now you're just doing, and that's because pi is a constant. If it's a variable, this doesn't work. If it's a variable, we've really got problems. We can't have 3 variables, so we don't have a product rule for 3. Okay, so now, if the pi's out front, r squared h, what are you doing?
2R dr.
And what else still has to be there? H, because it's product rule, yes? So derivative of r squared is 2r times dr dt, keeping the h. And then plus you keep the r squared, derivative of h is 1 dh dt. This might be a needed break because do we have everything we need to fill in? I mean, we need r, h, dr, dt, and dh dt. We have all of those in this scenario, don't we?
Oh, yeah.
So fill in. You don't always have everything, so, Okay, pi 2 times 4 times 6 times negative 2 plus 4 squared times 5.
Okay, I have a question.
Mhm.
So on mine, I
Yes.
did when I differentiated it. It's like the first step with the pi's out front. I did 2r dr dt h.
Mhm.
And so then when I added it all up, I got 0.
If you're doing 2R dr dt h. This is all multiplying.
Yeah.
You're still multiplying the same numbers.
Yeah, when I multiply those together, 2 times 4 times. Oh, I wrote the wrong number. Never mind.
I'm like, you're still multiplying the same numbers. I'm not sure what you're doing, but
How did you get negative 16?
well, I'm not sure where at the end, negative 96 plus 80 is negative 16 times the pi. Basically the pi I just tacked back on at the end. For me, 2RH dr dt is 2 times 4 times 6 times negative 2. What did we do? We did something goofy.
I put 5 in instead of 6.
Raise the roof.
Because I just looked at the
You grabbed the, okay. And then over here, r squared times dh dt, so 4 squared times 5.
It's been so long since we used our calculator.
Right there we.
If you wanted to.
If it's
couldn't
multiplying,
you
you can just put it all in.
Uh-huh.
just get the decimal.
Come on, Ian.
Maybe. Oh, is that what you did? Did you do you have like a negative 40 something answer?
Negative 50.265.
So you just multiplied the pi in, whereas I just left it as pi. It depends what they ask for. In this case, it would be, I would most likely leave it with pi. I don't know. I mean, if it's a free response problem, they're either going to give you a direction or they're going to take either or, because it's equivalent either way. So. Negative 16 pi. dv dt means we have a label of,
Inches per second.
not inches per second,
What?
change in volume.
Inches. Cubic inches per second.
I wrote inches cubed per second, but same thing. So yeah, your negative 50 something is probably equivalent then. If it's, I was just estimating, like 16 times 3 is 48, so somewhere around. Okay, that was a little bit easier. If only they were all that easy. Okay, an inverted cone is leaking water at a rate of 1 cubic centimeter per minute. The cone has a height of 9 centimeters, and a diameter of 6 centimeters. Find the rate at which the water level is dropping when h equals 3 centimeters. Given volume equals 1/3 pi r squared h. Okay?
Which way is the cone?
Inverted cone means it is upside down.
Yeah, so it'd
It's
be-
like an ice cream cone.
But upside down.
The ice cream cone?
Oh.
No, like
We are ice cream cones.
this is an ice cream, or this is an inverted cone.
Oh.
So a regular cone would be like a party hat.
See, that looks backwards to me.
That's trivial. Hold on.
I don't know. This right here is what you learned as a cone. I know we always equivalent it to an ice cream cone, but a cone, like a party hat, like a pylon outside, that's a cone. Inverted means,
Ow.
okay. Anyways, there's your inverted cone. I wasn't even going to draw a picture right up front, but okay. They gave us a formula, which is the volume of a cone. Basically, it's 1/3 of what your cylinder formula is. Because cones and pyramids, they're 1/3 base times height. So 1/3 the area of the base, pi r squared h, times the height.
Oh, like a pyramid's 1/3 of.
Like a square pyramid would be 1/3 of a square prism, or rectangular prism type thing.
Huh.
Okay, what'd you give me?
dr dt is equal to negative 1 centimeter cubed per minute.
What'd you say it was? D what? DT?
dr.
DV
Would it be DV?
is volume.
I see what let's see.
The cone is leaking water, so it's a change in volume. Okay. The centimeters cubed is the clue there.
Oh, yeah, I forgot about that.
Okay. And obviously there wasn't an argument about the negative. What are we asked? Find the rate at which the water level is dropping.
So it'd be dv dq h equals 3.
I disagree with D. What did you say it was? DV?
Yeah.
I disagree there.
D
T? Wait, no. D,
DW
like diameter.
DA R
Water level is dropping.
DL.
What's happening? What's changing?
D depth.
Depth, which is what dimension of the cone?
DH.
The height.
Yes.
What?
I mean, depth, yes. But we don't have depth here. We were given what? Diameter? And I didn't put these information on there. We were given a diameter of 6 centimeters.
So can't we write in the given?
We could have, yes, and I didn't get that. I don't know why I didn't, but. And we were given a.
Height of.
So yes, these do kind of fall in the given pieces of information. Okay. Now, I'm going to write my formula. V equals 1/3 pi r squared h. And we're going to pause for a moment before we differentiate.
Time out.
Okay?
Height is the height of the cone. Well, wouldn't the rate of the height be the rate of what the cone is shrinking, not the water?
The cone isn't shrinking. The cone is a
That's what I'm
physical
saying,
shape. It's the water level is dropping. So it's like you have a water level here, then it's here, then it's here, then it's here.
But why do we
But the
use the height of the
has a
cone?
height. The water isn't necessarily.
Right, we haven't gotten to that yet.
Then it
lost.
should
Okay.
be dV.
It's still the rate at which the water level is dropping, which is the height of the water. So like the cone has a height of 9 centimeters, okay?
Oh,
We-
you're saying that DHDT
Is what's
the height
changing.
of the
Yeah, the height, the cone has a height of 9. And keep in mind, the water probably starts out at 9.
So we got two H's in it as well. Two different
We got
heights.
2 different H's. Yeah, we did.
I wouldn't,
We got
You
H.
get the height of the water.
I mean,
the height
think
of-
about it. The height of the water and the height of the cone start off the same,
Yes.
We should-
okay?
H
And so
one,
it's,
H two.
I mean, I guess you could kind of think of the height of the cone is changing because the water is cone shaped, yes? It's in a cone shaped mold, so to speak. And so as it's shrinking, yeah, you're shrinking the cone there. Okay, I'm getting ready. Okay, so the reason I had this pause here, normally we would differentiate, yes?
Yes.
I said pause before we do that. Because here's the deal. If we pause and look at this,
That's nuts.
I have an R and an H. Okay? The reason I'm having you pause and look at this, when we differentiate, we're going to have an R and an H, a dRdt, and a dHdt, yes?
Yeah.
In addition to dVdt. Okay, well, we were given dVdt. We're trying to find dHdt.
We don't know.
Do we have any information about dRdt? We do not.
We gotta find it.
So, we have to adjust this formula so that everything is in terms of H and we get rid of R. Okay? We're going to do this using similar triangles.
This is about to be when calc turns into magic. It stops being magic.
Give me a moment.
When the math problem doesn't work, just
Okay.
change the rules.
Right here, let me see.
Actually, those
Right here, you see me tracing a
Triangle.
triangle, yes?
Yeah.
Okay? And in this triangle, what do we know about this triangle? This triangle has a height of 9
Sorry, base of 6.
and Basically, it's the radius of 6, yes? Or,
Wait a minute.
3.
What?
What?
Oh.
a radius of 3.
Sure.
It is the base, I agree. I'm calling it the radius just because I'm trying to keep it in terms of a cone. It is the base of the triangle, I'm with you.
So we gotta do.
Are you with me why I said 3 and not 6?
Yeah.
Yes.
Okay.
Yeah.
Now, here's the deal.
A squared plus B squared equals C squared.
No.
Area.
Now, okay,
Not
the water starts this high, yes?
Yeah.
But then what's happening is the water is shrinking. Or it's, as the water is shrinking, the height of the water is down here now, yes?
Yes.
So now we have a smaller triangle to look at. But this smaller triangle we have to look at is what I would officially call similar.
Same
They're proportional, yes?
Yeah.
Same angles.
angles.
Geometry.
Okay, so now what I'm going to do is I'm going to call this H and funky R. Okay, and I guess I probably shouldn't have put H equals and R equals over here now that I think about it. Because what we're going to do is you guys remember similar triangles,
No.
That
I don't
was so
know
long ago.
how to solve them, but I don't know.
where we can set up a proportion.
Yeah.
Where proportion between the two triangles. There's a couple different routes I could go here. What are you guys a 3 goes to with 9 as R goes over H?
Sure.
Yeah, I can be.
Or are you 3 over R and 9 over H people?
Sure.
I don't even remember this.
I think
Okay.
I like the other way.
I think this was like a whole 4 years ago.
This is freshman.
I'm going with this was probably middle school.
Oh, even worse.
Is this algebra 1 or is this geometry?
Algebra 1 or pre-algebra.
That could have been 7th grade.
Exactly. Exactly.
We're
Did we
talking.
even have something? Yeah.
Six.
Okay. Now, stay with me, guys. Are you seeing my connection of similar triangles? 3 over 9. So basically, the radius of the big triangle to the height of the big triangle is proportional to the radius of the small triangle over the height of the small triangle. Yes?
Sure.
Okay. Now, what I'm going to do, I'll go with it. I just saw Augie mouth it.
1/3.
3/9 is 1/3. Could I reduce this and say 1/3 equals R over H? And it's not that you'd have to, but we're going to do that here in a moment.
Sorry.
I'm wanting to get rid of R in that formula. I need it gone.
R equals what?
Solve this for R.
Times H.
Think.
1/3 H.
What?
Cross.
H over
I think cross products, cross multiply.
Yeah. Yeah.
So, like,
Wait, how does cross multiplying work?
okay, 3 times R
H over 3.
is equal to 1 times H. Multiply your diagonals.
Okay, but like, why can you do that?
Because it's cross multiplication.
Okay, but
When-
why?
Because it's how it works.
Okay, whatever.
Because it's the
I'm
same
trying to
as-
get there, Caitlin. I'm
It's the
trying.
same as timesing by each side.
Timesing?
To the other side.
Timesing?
Yeah,
Does that not
it
work?
is. It is.
Oh, because
Okay.
then it'd
Do
be
times
1
sing
R.
yet?
Times.
Can't we just
How about the
Okay. Hey. Okay. Okay. The idea here is 3 times R equals 1 times H. This would be the same as if you were trying to, it's a shortcut for clearing fractions out. If I was trying to clear fractions out, I'd have to multiply by 3 and H because those are my denominators. When I multiply this side by 3H, 3's would cancel and I'd have 1H. If I multiply this side by 3H, H's cancel and I have 3R. And so I'm at the same 3R equals 1H. Okay. I mean, we call it cross products. It is essentially the same as clearing out the fractions, except no one ever likes that. But you guys like cross products generally. You guys just don't even remember it at this point is what I'm getting. So what I know is if I solve this, R is equal to 1/3 H, H over 3. Okay.
Plug that in.
We're going to use that, exactly, and we're going to plug that in over here for R. And we're going to clean it up then. So V is equal to, we still have 1/3 pi. What am I putting in for R? 1/3 H quantity squared, because it's R squared, times H.
Oh, we haven't even taken the derivative yet.
Oh, but we're going to clean this up more before we dare do something like that.
Okay.
Let's see. 1/3 pi, 1/3 H times 1/3 H is going to be 1/9 H squared times another H. I don't know. I want this as one expression. Multiply all that jazz together.
All of it?
Yeah.
Like to get a decimal, or am I
No,
ignoring pi?
fraction.
Oh wait.
Ignoring pi. I just want fractions, variables, pi still in there.
What's
1 over 27
pi
H
h
cubed.
cubed? Jinx.
Now, you guys said 1 over 27 pi. I will say pi over 27 h cubed is equivalent. Now, is there anything wrong with 1 over 27 times pi h cubed? No. Okay. That is our new formula that we're starting with.
Now we
Now, differentiate. Derivative of v, dv dt. Derivative of pi over 27 h cubed.
Oh, 3 pi 27 h squared times dh dt.
3 pi over 27 h squared dh dt. Yes? And we should be able to plug everything in.
I messed up. Hold on.
What is dv dt?
Negative.
-1. Now, I'm going to go ahead and reduce. 3 pi over 27 is pi over 9. H squared.
3 squared.
3 squared times dh dt, which is what I was trying to solve for.
Doesn't that just turn into pi?
It does.
Negative pi.
So I'm assuming where Caitlin was, pi over 9 times 3 squared.
Time out.
3 squared is 9. So then you're at pi over 9 times 9 over 1. The 9s can
Oh, that's
cancel. So that side is just pi with the dh dt. I'm assuming that's what she was referring to. Then I just divide by the pi. So dh dt is -1 over pi.
Yes.
Done?
Done.
Hold on.
Yay!
Other than label. It's a change in height. So it's a, what was our label here? Centimeters per time. What was our time? Minutes.
It's not cute.
Because we're changing the height of the water.
Yeah.
It's not volume.
Remember we already had that whole big discussion.
Right.
Okay, guys. So the big deal here of why we had to do this, we had no info on drdt. And so that's when R became, we had to go to R defined in terms of H. That was the big deal because we had no drdt. Okay? Good. Now, I would like to do A. This whole lamppost problem, walking, yeah, shadows, yeah. Okay. A lamppost is 26 feet above the sidewalk. Andy Great, that's his name. It's a play on calculus words. We're going to learn how to integrate second semester. Integrate. So Andy Great is a play on words. Andy Great, integrate.
I don't like that.
I don't get it because I don't know what they're
And I think she put it in here, and I'm like, man, that's a good play on words, but you guys don't really know anything about that. So okay, Andy Great is a 6-foot tall calculus teacher. Is walking away from the lamp at a rate of 4 feet per second. When he is 20 feet away from the lamppost, find each of the following, which I'm only working about A. A is your typical calc question. How fast is the length of his shadow changing? Okay,
He's got a big stride.
Yeah.
so
Why does his height matter?
a lamppost is 26 feet above the sidewalk. So the lamppost is 26 feet tall. I think that's a weird way to say it, but that's what they're saying. And then Andy Great is a 6-foot tall calculus teacher.
Probably because we have to do that stupid triangle thing again.
Oh, I see it too.
Oh.
Right in his head, isn't it? Yeah, I see it now.
So you are seeing that there is a big triangle, yes. And there's going to be a small triangle.
It could just give us.
I see so many.
Okay, I'm looking at big, the
Oh,
whole thing, and little.
oh, see, I wasn't looking there.
What are you looking at?
I was looking.
Were you looking at trapezoid?
Yeah, but like you split that into a triangle and.
Oh, okay.
Oh, I see.
So here, for reference, the small triangle, the left side is 6. The big triangle, the left side is 26. Are you seeing the two triangles now?
Oh, no, yeah.
Ratio.
I see it.
Okay, so we are going to talk ratios here in a moment. Now, with this in mind, he's walking away from the lamp at a rate of 4 feet per second. When he's 20 feet, how fast is his shadow changing? Basically, we have two pieces right here. We have this piece, and then we also have this piece here. We don't know either of these lengths right now.
Yeah.
Okay? I mean, yeah, there is when he's 20 foot away from the shadow or the lamppost, but that's when. That's not all the time. So I'm going to call these X and Y. Now, what does that mean the bottom side of my small triangle is?
X, Y.
Just why?
My small triangle has a height of 6 and a base of Y. About my big triangle.
I had a 26 base of X.
Wouldn't it be X, Y? Because it's the whole thing.
Yeah.
Oh, wait, yeah.
How about X plus Y?
Oh,
No.
yeah, that makes sense.
I mean, yes, it needs X and Y, but let's put the plus sign in there, please. It's not X times Y.
Just make it.
Now, let's,
You should pick it.
okay, lamppost, Andy's height. He's walking away from the lamp at a rate of 4 feet per second. What is that 4 feet per second?
D,
D base.
length, D,
Distance.
distance.
Okay, so he's walking away from the lamppost. What length is changing?
X.
His shadow.
X.
X.
Oh, X plus Y. No, X, yeah, X.
He's walking away, so Andy is right here.
It's just
He's
X.
walking away from the lamppost. So the distance from him to the lamp is changing at a rate of 4 feet per second.
Yes.
When he is 20 feet away from the lamp,
When X equals 1.
so when X equals 20, we're looking at how fast is the length of his shadow changing. Where is his shadow?
Y.
Behind him?
Run.
Oh.
The light is shining from behind him, so his shadow is
In front of him.
in front of him. His shadow is Y, so dy dt is what we're being asked to find. Are you with me here?
Yeah.
I suppose.
But we don't have
Okay. But we do. You guys already mentioned that we have
Oh,
two
yeah.
proportional triangles. Okay. So we're going to set up a couple of proportional triangles. Set up your ratios. What ratio do you want to use? 26 over
6.
6. What's that going to be equal to?
X plus Y over Y.
Yeah, that is.
X plus Y over Y. Are you guys there?
Sure.
This is similar triangles. This is literally middle school math to pre-algebra type.
That was a long time ago.
I taught this when I taught 7th grade math, and I didn't necessarily teach.
Okay, then that could
My
be
honors
sixth
kids were
grade.
pre-algebra, so it could be 6th grade. Yeah. Okay. Now, before we differentiate this, I don't want to differentiate this and this one.
Oh.
How about I would say cross products, or let's get rid of your denominators. Multiply both sides by 6y.
Oh.
Yeah,
Like, in other words, if you multiply by 6y,
I understand.
Then you get 26y.
Which is a cross product.
I understand it now.
it clicks. Okay.
By 6y or
6y.
Same thing.
Wouldn't it be 26?
But what if? But then you're. Oh
Okay.
no, I see it now. Sorry.
Remember Kim?
I
It
understood
wasn't
it.
Kim.
I understood it, and then I confused myself.
Yeah, or maybe it was just me, but Doc would just always say just cross multiply, and then I'd be like, well, what the heck is cross multiplication?
Okay, so this is mathematically what cross multiplication is. We're clearing out our denominators. 6's cancel. You have not 2y. You have 26y. Y's cancel. You have 6 times x plus y. Now, I would much prefer to just do what Doc did and say cross products. Because 26 times y, 6 times x plus y. That's why I say cross products.
But you can only do that when it's equal to.
When it's a fraction equal to a fraction. It doesn't work when you have fraction plus fraction equal to something. No, it only works with fraction equal to fraction. Okay, let's keep cleaning this up a little bit. 26y equals 6x plus 6y. Subtract 6y, and now I now have 20y equals 6x. Which way do I want this? Let's solve this for y.
For y. We got y equals 6x divided by
6 20ths.
6 over 20.
6 over 20.
Or 3/10.
3/10 x.
Yep.
Okay, there's the formula I'm going to use. Let's differentiate. Sorry, I'm trying to move.
Let me take a derivative.
Yes, when I say differentiate, take the derivative. Derivative of y,
dy dt
dy dt. Derivative of 3/10 x.
x. No, 3/10.
Oh, I forgot about the
3/10 dx dt. Okay,
And then you plug it. Wait,
Can we just go?
yep.
Nice.
dy dt is what we were supposed to be finding, yes? 3/10 times dx dt,
Which is 4.
which is 4.
3/10 times 4.
So
12/10
12/10,
or
6/5. My brain's wanting to say 1.2, but I have it as 6/5
6 feet per second.
per second.
Holy crap. So the
That was
20
crazy.
seconds didn't even matter.
The distance of 20 feet didn't even matter.
Oh,
Why
yeah,
are they
that's
telling
what
me
it
stuff that I don't need to know?
Because they're trying to confuse you.
Magic.
Now, folks, I'm going to tell you guys, this whole shadow thing,
That I don't like
you've seen that in other levels of math,
shadows.
okay? Doing
I've
similar
never had to
triangles,
think
you've
about
seen
which way the
shadows.
shadow went.
I have.
Okay,
This-
but the lamp is shining from behind you.
You did that in pre-calc. There was some shadow thing.
Yes.